Hello, everybody. Welcome to the NVIDIA Omniverse live stream. Super excited for today's episode. Thank you all for joining us. We have very special guests and NVIDIA Inception partners here, Foxglove. They'll be joining us for the second half of this live stream. And the first half, we're going to go over Isaac Sim, Isaac ROS, Isaac Lab. And basically, if you're into robotics, this is going to be a great live stream for you. Before we get started, quick announcement. I wanted to share that the free OpenUSD training courses are now available through the NVIDIA Deep Learning Institute. We'll post a link in the chat. These are modules that have that go over the foundations and all the OpenUSD material that you would need to start as a developer. And they're very progressive. And you can also leverage the OpenUSD study group that happens weekly every Tuesday on the Omniverse Discord if you'd like to chat about those modules and those courses. So it's a free resource to everybody who really wants to dive into OpenUSD, especially if you're want to get interested, want to get started with developing. Before we have our special guests, I want to invite our internal very special guests. We have two very special members of our team. There's Kalyan right there, and using the latest technology, just warped in Akil. Hey, Akil, how you guys doing? So this is a very exciting live stream. We have an extreme amount of interest in the community for robotics. And NVIDIA obviously is super active in this area. We're going to talk about the tools we have and the applications and the platform that makes this all available. And super excited. Like I said, with the second half show, we're going to have Foxglove on there, who's waiting in the wings. They're going to show off their work. But why don't you guys start by introducing yourselves and starting with Kalyan and with your kind of role in NVIDIA, what you focus on.
Hi, Edmar. Great to be here. My name is Kalyan Vajrevu. I do product marketing for our acceleration libraries and models that run on the robot. So very excited to talk about the stuff that we're doing today with my colleague Akil.
Awesome. So glad you're joining us. And Akil, thank you for joining us. I can see you guys are both at headquarters. It looks like a lot of activity in the background. Great.
Yeah, thanks, Edmar. Thanks, Kalyan. Yeah, so super excited. As Edmar said, my name is Akil. I work in product marketing. My background is in mechanical engineering, and in fact, my undergrad was in robotics, but I moved away from that. I went into simulation of different type, which is fluid simulation, the ones that you may have seen for, airflow on a car or on a car or on a plane. So that was what I did for the last 20 years or so after school. But life comes back full circle, so I'm back in robotics. But again, my first love, which is simulation. So pretty excited to kind of talk about a different aspect phase of my life. So super excited to be here talk about robotic simulation.
Well, great. So, and I know you have a great presentation we're going to see in just a minute or so. So welcome to everyone who's joining the stream. If you're just joining us now, we are covering robotics and Isaac Sim and Isaac ROS. I have a very special guest here. The title of the stream is interesting: a simulation-first approach to developing physical AI-based robots with OpenUSD. So we're going to be showcasing workflows that developers can use to enhance their robotic systems with Isaac Sim, but we're also going to cover some other areas, like I mentioned, Isaac ROS. And we'll go over into the differences, which can be a little confusing if you're hearing it for the first time. So Akil, I think you have a great presentation available. Let me go ahead and bring it to the screen.
Please. Yep.
And here we go.
Make it full screen.
Full screen.
Yeah, how about that? That look okay?
There you go.
All right. Awesome. All right, let's do it. So yeah, I'm here to talk about robotic sim, and then Kalyan's going to talk about a little bit about Isaac ROS. We're going to touch on it, but today's focus is really on simulation. Like I said, it's very near and dear to me, and super excited to sort of talk about this aspect. But before I jump in, I also, Edmar, I know that you help our community developers. I just want to sort of thank the community developers for A, making time to be here, and B, also for adopting our technology and tools in their own workflows and building something awesome. So that's definitely really cool to see. But more importantly, the feedback that you give us to make our products better is also really important. So I just want to give a shout out to all the community members here who are just taking our tools and building something awesome on it. And then, your feedback gets back to the product. And then essentially, as we make the product better, we bring in more community developers. So your work is really helping bring in more developers to our community. So I just want to take a moment to thank all of you for not only attending, but also helping move towards the next phase of what would be pretty awesome in terms of NVIDIA tech as well.
That is so true. And actually, it's a great point, because if you are working on a great project and you want to kind of share it with the community, you can share it on the Omniverse Discord server. We have a Share Your Work channel, but you can also potentially present it on the live stream. So we're planning a few live streams revolving around robotics. So just reach out to me through email, edmar@nvidia.com, if you're interested in kind of showcasing your work, either one of those ways, and I'll help you. And then also feel free to start posting your questions or comments throughout this live stream in the chat. We're going to be monitoring that closely and posting any relevant links along the way. So great a great shout out to the community there, Akil. Thank you.
Yeah, thanks, Edmar. All right, so let's dive into it. So as robots are cool, they've been cool, and they're going to get cooler and better and pretty awesome in the near future. And what's going to make them better and essentially autonomous and essentially make them very human-like is physical AI. It's the amalgamation of all the things that you see here: perception, cognition, functional safety, dexterity and manipulation, navigation. These are all the elements that we as humans naturally possess. And over the next few years, we're going to be imparting that to robots, because they're going to make our lives a lot easier. And as we move towards that AI-based robots, there's a lot of challenges that many developers need to overcome. Even if you take about perception is not just about seeing, but it's also classifying, it's segmenting, it's detecting. Dexterity comes in many different ways, like gross and fine motor skills. So the idea of bringing all that together to make a functional robot is pretty challenging. And we're there as NVIDIA. We're working really hard. There's so many engineers here who are looking ahead and seeing how we can make that a lot easier for developers like yourself to go solve that problem. How we see this breakdown essentially comes down to the 3-computer framework, or 3-computer problem. The first one is the AI that's required to train the model. These are the models that are going to be eventually deployed on the robot. Think of them as the robot brains itself. The second computer is essentially Omniverse, which is what we're going to talk about a lot of today. Is where you simulate the behavior of the robot. This is where robots learn to be a robot. This is your virtual playground. This is where you try many different things on the robot to see if it passes or fails those different tests. And finally, when you're happy with what the robot is doing, then you can go deploy it on the real physical robot itself. But you can see this loop is connected, right? So if I deploy the final robot stack on the model, I have a way to collect real world data now. And as the robot is operating and behaving in the real world, I can collect that data, figure out where it's doing the right things or not doing the right things, but take all that data and feed it back again to my AI model to make the AI model better, go back into simulation to then ensure that all the new elements that I've added to the model actually work, and then bring it back to the robot. So this continuous or virtuous cycle is really important, and that's all dictated by these 3 different computers here. One for training, one for simulating, and the final one is deploying, and they're all connected by this circle. If we just look at it in a different way, maybe perhaps look at it from a perspective of a workflow, I like to lead with the sim first idea of it. On the left-hand side, if you've been in the world of developing robots, then the starting point is always data. The data can come in many different ways. It can come in the form of simulated data, simulated experience. It can come in through a teleop. It can come in through a text, image, and or video. These are sort of like the normal ways to absorb or ingest data to, if you take a look at the top line workflow to train the model. Here's where you select the model, could be your object detection model. You train it, you validate it, you optimize it. And then when you take that model, now you can then put it into simulation. There's 2 ways to do that. One is to be able to ensure that the robot can learn along with policies. If it's a perception-based thing, then it needs a perception model, it needs the policies. You set up an environment, and then you train it, and you ensure that the robot can do the same action over and over and over again, and eventually it learns how to do it properly. So, a lot of you might know that as reinforcement learning, but that's one aspect of teaching a robot. Once that entire robot stack is ready, then you can also use simulation to test and validate that. Let's throw a multitude of different scenarios here. Let's simulate that, let's analyze that, let's iterate and continue. And again, our friends from Foxglove are actually going to be talking about, as a developer, how can you sort of think about analyzing what went right and what went wrong? Because root cause analysis is really important. And the technology that they're building is really awesome and lends itself nicely to the sim first aspect at the end of the day. So the question might be, well, why is Akil here talking about sim first? And again, I go back to 20 years of my life and all the work I've done in simulation. A lot of that is transferable from a different industry to this. From a sim first approach, allows you to bootstrap your AI model training. We'll talk a little bit about that later on in the slide, where the need for synthetic data generation arises when you're training AI models. It allows you to do scalable testing. And when I talk about scale, I'm not just talking running on multiple GPUs. I'm talking about the scale of the robot itself. You could have a single robot in a work cell, or you could scale it up to multiple robots in a massive warehouse. So how do you sort of test multiple robots running multiple perception stack in real life? Right, it can be pretty difficult to do. So simulation gives you a way to scale up your testing there. As again, this is very common to the world I came from. Simulation was the sim first approach allows us to reduce the number of prototypes. One example I can relate to is that as a simulation engineer, I was doing testing and design of computers for heat removal. So think about the fans and the heat sinks that are there in a chassis. We would build a simulation model first and run it through different types of iterations, and then we would go to the lab. And then when we knew which iterations would work, we would apply that same in the physical testing. So I didn't have to have my colleague go out and say, okay, you know what, swap out this fan with that fan, swap out that heatsink with this heatsink. Let's put a extra hole here so we can have more air come in. It was all about vetting that out in simulation and then going to the actual physical chassis and then trying out maybe a couple things there, because I've already looked at the design space. So it really allowed me to fast track my process, but also ensure that my colleague didn't have to build 5 different types of physical models for me, which maybe at some point wouldn't even work when we're doing the testing. And the last part is, especially when you're working with machines that move, safety is paramount. And so the benefit of sim first approach is that it allows you to have your own safe proving ground. You can try multiple things. The robot might fail at it, but at least you know that it's not running around the real world. And so it's a nice way to put boundaries around where your proving ground lies. And again, simulation gives you, in addition to these 4 benefits, it obviously gives you many more, but these are the 4 really major ones where the sim first approach really provides that benefit for you. And so Omniverse is essentially where physical AI is born. And Omniverse is a platform. If you've been to many of the live streams that Edmar and Amelia have run, along with Stephanie, this is really what we're presenting to the world. It's a collection of APIs, services, and SDKs that really allow you to build your own 3D simulation workflows. But not only that, you can build on top of it, or you can pick and choose the key components and APIs and plug it into your existing workflow. So we're super flexible in how we work with the developers, and we want to be able to push that forward. We want to be able to have your workflow supercharged. So again, Omniverse is not a tool, it's a platform, and you can pick and choose the APIs and services and build your own custom simulation workflow. And when it comes to robotics, there's so many different types of workflows, so many different types of robots. And so the flexibility and modularity of Omniverse, because it's built on OpenUSD, really lends nicely into that next level of robotic simulation. So I talked about Omniverse as a platform. And as we were talking to a lot of roboticists out there, one of the things that they said is, well, can we think about robot simulation? And so NVIDIA Isaac Sim is a version or a reference application built on top of Omniverse. Again, it's a developer platform, so it's not an end application by any means. It is something that you as a developer can pick up and build on top of it. Again, Foxglove was going to show you what they did. Again, proving that it's a developer tool. There's a lot of different ingredients in Isaac Sim that you can use for your robot training and also robot testing. I'm going to touch on 4 of them. But the idea again is that you can use Isaac Sim as a whole to build your own sort of robotics workflows, or you can pick and choose the components of that to integrate into your existing workflow, or you can build your own extension that could be a visualization one, could be anything that you want to do. So again, the value of the platform comes through, but Isaac Sim is sort of purpose built for robotic simulation applications. So I'm going to start with, if you will, picture this along with me as I sort of build the story for you. Simulation starts with building a scene, and that scene could be a single work cell where a industrial manipulator is moving things around. Could be a massive warehouse where there's multiple of these these robots there. It could be a house where you want to run around, you want to test how your household robot is going to behave. But whatever that is, that's your scene. That's your virtual ground that you're going to build everything in. And the idea there is you want that to be as physically accurate as possible. Not only photorealistic, but physically accurate as possible. And so, again, with the power of OpenUSD, we're able to work with all the different tools out there to bring in 3D scenes, make them extremely photorealistic. And then we're also, our internal teams have worked really hard on providing what we call sim-ready assets. And again, these are available for you to use in Omniverse and also in Isaac Sim. And sim-ready assets have, they're they provide you with a really awesome starting point. For example, we have conveyors, we have pallets, we have forklifts. And as you start building your scene, you can leverage these sim-ready assets. One of the things that is nice about sim-ready assets is that they're obviously, flexible because they're built on OpenUSD. They're photoreal and physically accurate, so they have all the right physics and materials and attributes built into it. But as we talk about perception, and again, if you go back to my first slide where we talked about the perception part of the robot, sim-ready assets come with preloaded metadata for annotation. I want to know if that's a cone. I want to know if that's a drum that fell off. So you can see here the segmentation, the bounding boxes, they're all attributes that are part of sim-ready assets. So again, a great way to sort of start building your scene. And again, sim-ready assets are there. I believe we have more than 1,000 sim-ready assets. Our team is working really hard, and you have an awesome library to leverage as you start building your first step, which is building the scene that the robot will be a part of. The second one is, now that you've built your scene, well, what kind of robot? And so robots come in many different types. We have humanoids, we have industrial manipulators, we have quadrupeds, we have AMRs. And so again, working with our ecosystem, this is why it's really important that we work with all of you, is we're able to then absorb their libraries into Isaac Sim and give you an awesome starting point. So for humanoids, we have agility and Fourier. Manipulators, the big names that you can recognize: KUKA, UR. Quadrupeds, Boston Dynamics Spot Robot, that's really popular if you've seen that. AMRs, Ideal Works, and iRobot, which is your home robot. We have the starting point for you, so you can just build your scene and bring the robot in. But let's just say that none of these robots or none of these library items really appeal to you, or maybe you already have your own robot model. Well, you can import that using URDF, MGCF, or Onshape and ShapeNet. So we have different format supports for that. URDF, I believe, is really popular in the robotics community. So if you have a URDF robot file, you can import that into Isaac Sim. Again, think about like the story I'm building here. You got the scene, you got the sim-ready assets going in there, OpenUSD to be able to import new scenes, new backgrounds, robot models ready to go, or bring your own through URDF. So now that we've done the scene and the robot, what's next? Well, the robot has to perceive, it has to sense its environment, it has to sense its surroundings, and that's where sensor models come into play. Again, just like the robot models, we have libraries for camera and LiDAR sensors. So there's two types of sensors you can or two broad category of sensors you can work with in Isaac Sim. One is perception-based sensors. These are your camera, LiDAR, and radar. And physical sensors, contact sensors, inertial sensors, force sensors, proximity sensors. So they're all part of Isaac Sim. Again, these are really important pieces that a robot needs to have so that it can sense its surroundings and maneuver and manipulate as needed. Let's just again pretend that you don't want to use any of these and you said, Akil, I just want to use my own or build my own. We have pre-built extensions in Isaac Sim that allow you to build your own camera, LiDAR, or radar sensors. So again, use what we have or build your own. Again, very flexible from a development standpoint. So we did the scene, we did the robot, we did the sensors. What's next? Physics. Without physics, physical AI is not possible. And again, kind of going back to physical AI, the whole point of a robot is that it needs to operate autonomously in a physical world. And so physics is the underlying thing here. And again, PhysX, if you've heard about it or not heard about it, is an SDK for modeling and simulating physics. It's an open source that you can go use on its own if you wanted to, or it's also already integrated into Isaac Sim. Some of the key features that PhysX brings to the table are things like rigid and soft body dynamics, joint modeling and articulation modeling. So if you put a force on one side of the joint, well, the other joint is going to move in a different way. So you want to be able to model that accurately, and that's why PhysX does that for you. Contact modeling, again, if you see on the video here, the gripper is rotating the nut. So again, what does that force look like from the arms to that nut is really important. And so, again, contact modeling is there. Vehicle dynamics, again, these are for your AMRs. What are they doing? Does it bob up and down? How are the wheels turning? What's the friction when the wheels are moving on a ground, soft, like a plain rough surface or smooth surface? What does that look like from a friction standpoint? And then finally, if you're modeling robots and humans together, then you want to have characters in there. So what's the kinematic controller for the characters? So PhysX is really powerful, allows you to sort of build your entire robotic simulation. So I wanted to sort of give you an element of all these 4 different really important ingredients. There's so many more features in Isaac Sim, but these kind of drive your major setup for your simulation. So now that we talked about the 4 ingredients, I want to touch base on what are the workflows that enable Isaac Sim. So you can see from left to right, I've kind of covered all the various options there. The workflows that you can enable from Isaac Sim or with Isaac Sim are synthetic data generation that leads directly to model training. And when your model is trained, you can do robot testing and validation, which is software in loop. But the other thing that Isaac Sim also lends itself nicely, because it's a development platform, is that you can build your own custom simulator. And I'll touch on that for Isaac Lab, which is specifically meant for robot learning. And when you go through all of these, essentially a validated robot stack comes out. And what binds all this together is Osmo. So this is it's an orchestration service specifically for robotics workflows. So let me touch base on these 3 at a high level, and then we'll go through that. So the first one is synthetic data generation. So for those of you who are new to robotics or just new to AI model training, the biggest hurdle that most developers have when training AI models is data. Either it's restricted because of privacy reasons or whatever it might be. It's limited. There might be something there, but it's limited because there's not enough of it. Or it just doesn't exist because it's such a new use case that nobody's ever thought about collecting data for it. So how do you train a model when there's no data? And this is where synthetic data generation can come into play, because using your simulation scene, which is the first one that you see here, Isaac Sim has many different features where you can do domain randomization. Here you can change the color, you can change the texture, you can change the background, the lighting, and really kind of build that diverse data set. And then when you run through the randomization process, you can then generate annotated images. In this case, you see a bounding box, but you can have depth, you can have segmentation masks. And again, depending on the type of model you're going to train, you can have that data written out so that you can go train that model. What's cool about synthetic data generation is that if you wanted to change something, you could go back in the pipeline and change the color. Maybe that's what's affecting the model metrics, or maybe it's the lighting that's affecting it. So again, the automated pipeline allows you to do that. Not saying that you don't need real data. You definitely need real data to validate your final model. So if you have real data, by all means, please use it. Merge it with the synthetic data or use it for validation, however you want to use it. But again, synthetic data gives you a nice way to get started with that. So especially with the robotics use case, synthetic data is like the first starting point that many roboticists start with. When the model is trained, you want to be able to test it. Again, there's a workflow for doing software in loop. You have your model, it's all ready to go. It's sitting somewhere, and then you have your test configuration that you're going to say, I want my robot to move 5 feet, and I'm gonna put an obstacle in front of it. So what is that scenario? How should that scenario play out? Should the robot stop immediately? Should the robot see the obstacle and turn right, turn left? Those might be your scenarios that you might be testing. And so you send that over to Isaac Sim. You set it up in Isaac Sim. Isaac Sim then exports out the rendered frame to the AI model. The AI model is connected to the robot stack, and then it then says, all right, Akil wants the robot to stop. And so it'll look at the box and go, okay, I see an obstacle in front of it. It'll say that that's a box. So robot, please stop. it'll send the signal to the robot stack, which then actuates, and then you'll see the result in sim. The robot should stop when it sees the obstacle. So this is a closed loop thing that we were talking about, which is again possible through Isaac Sim. And the last one I want to talk about is Isaac Lab. Isaac Lab is a lightweight Isaac Sim based application specifically built for robot learning. So now that you've trained your model, you've got your synthetic data, you want to bring that robot into a world that it's never seen before. And you want to test it against a lot of different things. We take things for granted when we pick up a bottle like this, but for a robot, that action needs to be done over and over again so that it's perfected to the point where it's efficient. It can do it in a repeated way and do it in the fastest way possible. Because I can approach grabbing the bottle from the top, from the side. There's so many ways to approach the problem, and so robot learning allows you to do that. So a part of that is different mechanisms, as in reinforcement learning, imitation learning, which is see what you do and then repeat that in simulation. But again, if you go back and think about what I've talked about so far, is all sim first, right? You're again teaching a robot to be a robot in this. So if you were thinking about robot learning, you would want to go take a look at Isaac Lab, but it's got all the elements of Isaac Sim, which is the Isaac Sim core, and it's a lightweight open source application that you can sort of use for robot learning. So we talked about SGG, we talked about SIL, and we also talked about Isaac Lab, which is essentially, think about it as a custom simulator. I did mention in my workflow slide about Osmo. And what's great about this is the fact that if you think about from a robotics development perspective, everything's sort of sequential and they're all connected. You ingest data, maybe real world data, maybe synthetic data, whatever it might be. You process the data. You might also do data set generation, which is the SGG part. Then you do the AI training, you do the software development, you do validation, you release it. And that's a cyclical process that we talked about. But for most people, and most cases, this is done at scale because you may have a large team of developers doing different things, right? I could be doing synthetic data generation only, while Edmar is doing AI model training, while Amelia probably is doing something else. But we're all connected as part of the tool chain. And so the issue that usually happens is I need resources to do SGG, which require a certain types of GPUs and certain number of GPUs. Edmar requires really amazing horsepower to train his AI model because that's going to take a lot of time. And Amelia might require something else. How do we connect all three of us without actually asking me, Edmar, or Amelia to think about infrastructure? Oh my God, I need L40s or I need A100s or H100s, whatever it might be for training. Osmo removes that layer of complexity. So think about just about the work you need to do, and Osmo ensures that the workload that you're asking for is then deployed on the appropriate GPU across a heterogeneous infra. Could be something that you're running locally or could be in the cloud, doesn't matter. Osmo can orchestrate that. So I could be doing synthetic data generation. I can just say, look, I just need 4 of these GPUs. And Edmar can say, look, I'm doing heavy duty training. I just need this model and this GPU, and please make it happen for me. So Osmo will orchestrate all that. So as we go from sort of like your local robotics software development and simulation to large scale, Osmo really lends itself nicely to take that workload and scale it up. And this is what binds everything together. If you notice when I put that workflow slide there. I'm going to end with one story, and this is really cool. And then I'll hand it to Kalyan to talk a little bit about Isaac ROS. All the things I talked about up until now, this story is sort of an amalgamation of that. So most of you have heard of Delta Electronics. They're like one of the largest OEMs out there who provide power supply units. I mean, that's their primary business, amongst other things that they build. The issue that they were having in this supply chain was the chassis would come in, and they had to figure out how the robots could understand the orientation of that chassis. And as the chassis is moving through the rollers, it would be misaligned. It could come in at an angle. And the idea was that, well, how do we ensure that we can put it in the right pose and detect the right pose? Because, a component might be top left, or it could be at the bottom right, depending upon where the orientation is. And they wanted that to be in one certain orientation. And this is also useful for A, for putting the right parts in the right location, but B, for detecting any potential defects that are down the line when you're finishing the manufacturing. And so their idea was that, what can we simulate that? They were already using Omniverse and OpenUSD to build their assembly line to simulate the workflow. Then they used the same simulation scene to then generate synthetic data. Because up until now, they were manually taking pictures, or I saw one video where they were recording from top and looking down, and they would take a bunch of videos and pictures and then use that data to train. But in a live assembly, that's very difficult because anomalies don't happen that often, and when they do, they're difficult to capture. So with using simulation Isaac Sim, they're able to create thousands and hundreds of thousands of images to train their model, and that really is that speed of training that they're able to quantify for us. But not only that, because they're able to grab the data and look at multiple different use cases, they were able to increase their accuracy up to 90%. Obviously, off the bat, it's awesome, but because they've deployed it and they can start collecting real data, they can sort of improve the accuracy over time. Just like we talked about in the 3-computer framework, train the model, simulate it, and then deploy it, and then keep learning from that loop. So again, bringing everything together that I talked about, Sim first, is really the value that you can see here. And there are many other developers and customers who are using Isaac Sim to reap the benefits of a Sim first approach. So I just wanted to share the story here about how Delta Electronics improved their assembly line. With that, I'm going to hand it to Kalyan, and he's going to talk about Isaac ROS and how that connects to Isaac Sim for a Sim first approach.
Thank you, Akhil. That was amazing. I mean, I think you painted the picture really well on the training, simulation, and I'm going to talk about deployment then. So it's 3 computers: train, simulate, deploy. And Isaac ROS is our way of bringing hardware acceleration to ROS developers. As you can see in my in my title, I am all about ROS developers, and Isaac ROS brings hardware acceleration. So as Akhil mentioned, our goal is to accelerate each of these workflows: training, simulation, and deployment. Isaac ROS is built on top of ROS, and it offers advanced features to build smarter and more intelligent robots. So for example, there's advanced mapping, localization. For robot arms, there's motion planning, object detection, and tracking. So you see those accelerated packages in the stack right there. As an engineer, I'm just showing you the stack, but I think most of you will relate. At the second row from the top, these are the packages, these are the key use cases that you can enable with Isaac ROS. And once, what is actually happening is, once all of these robot models and associated stack, they have been trained, they've been optimized, they need to be deployed. And there is the acceleration libraries that support as the stack is running on, let's say, on a Jetson board. And I also want to link it back to simulation, how it links back to simulation. So for example, Isaac Sim can run on a separate machine, while Isaac ROS runs on the target hardware, like for example on Jetson, right? So you can test your software on Jetson, interfacing with the simulated environment. So that's how it all comes together. I think that's briefly what Isaac ROS is. It is accelerated packages that enable you to do specific use cases. The 2 things that we are super focused on are manipulators, industrial arms, and autonomous mobile robots, the robots that move around warehouses. So you will see these workflows enabled by Isaac ROS. So please do check out. We've been running Isaac ROS live streams. Hedmer has been instrumental on it. So please go check out. We'll post the link. But without much further ado, I will send it back to Akhil. One last plug on Foxglove, who was going to present. We've launched last year a new data recorder package for multi-sensor data capture to ROS bags using MCAP, which is their contribution to open source. Back to you, Akhil.
Awesome. Thanks, Kalyan. Yeah, so thanks for painting the picture about where simulation and real world meet, and they both can coexist, and that's really the goal here. If something that I can try in simulation can be applied to the real robot and vice versa, then I'm closing the loop, and I'm doing that a lot faster. So pretty awesome to sort of link it with the actual robot. So this is my last slide. I'm not going to inundate you with any more slides, I promise, because we want our partners, Foxglove, to really talk about the cool stuff they're building. Again, just to summarize, simulation first approach is needed to unlock autonomy for physical AI robots. Robots that are going to be autonomous in the physical world. That's really important for us. Isaac Sim can be used for, it's a developer platform that you can use for building your own SVG pipelines, do software and loop testing, and also build custom simulators, as in for robot learning that I talked about for Isaac Lab. If you want to learn more, the single source of truth is the NVIDIA Isaac Sim developer page. Head over there. From there, you can sort of explore all different types of things. Osmo, Isaac Lab, check out the documentation. We have lots of cool tutorials, how-to blogs. Really just going to keep you busy all day just to sort of browse through the whole thing. So yeah, check out Isaac Sim and please let us know what you think on the forums, and we welcome all your feedback and suggestions. So Edmar, with that, I'll pass the ball back to you.
That was fantastic. Holy cow. Colleen, you said it perfectly. This presentation material is so good and compelling. So thank you, Akil, for assembling this really fantastic PowerPoint. I think everyone watching has been posting great comments, some amazing questions also, but very excited about the data we're presenting today. If you're just joining us, we are covering physical AI robots, leveraging Isaac Sim and Isaac ROS. And we're going to have a guest on in just a minute, Foxglove, who's going to show work about on their extension they've created. This link, if you missed the beginning of the live stream, this link is on YouTube permanently, so you can watch this later at your convenience tomorrow. It'll be here, and we'll update the description with some of these great links we've been sharing throughout. So thank you so much, Akil. That was really fantastic. All right, I'm going to remove that, and I'm really happy that we have this fantastic guest on, because I think it really speaks volumes when you are showing a case of a customer business leveraging this technology, and more so that they're sharing this with the world and the community. So this is fantastic. So really happy to have here. Let me warp him in here with a special tech. We got Robin. Hey, Robin. And we've got Bahram. It's really nice to have you guys on here with us. We're going to learn a little bit about Foxglove to get started. So I think, Bahram, you have a nice slideshow right here, right?
Yes.
Okay, awesome. So before you get started, why don't you just kind of introduce yourselves really quick and what your role is at Foxglove?
Cool. Yeah. My name is Brahm. I am the head of product here at Foxglove, and I've been with the team for about 2 years now.
Nice. And Robin?
Hi, everybody. My name is Robin. I joined much more recently than Bahram, a couple weeks actually, and I'm a software engineer in robotics, essentially working on integrating Foxglove with different robotics hardware or software platforms.
Oh, that's pretty impressive. You're 2 weeks in and you're already on the live stream. That's fantastic. That speaks volumes of your expertise. So it's great. I'm really happy to share, for those who may not be familiar with it, NVIDIA has a fantastic starter program called Inception, and Foxglove is a member of Inception. There's lots of great resources there for startups, and absolutely free. So I highly encourage you, if you're watching this and you've got a startup, and the definition is actually pretty flexible. You really just have to be within the last 10 years. We can share the link in the chat. Amelia's doing a fantastic job of sharing those links, and we've been starring your questions also throughout the live stream. So we're going to hit some of those questions toward the end of the show. So stay tuned for that, and keep posting your questions. All right. So Bahram, you're going to explain a little bit about what Foxglove is all about, besides having a great name and being an Inception member.
Yeah, absolutely. Very excited about it, and thank you for having us on. And also, fantastic presentation, Akil and Kalyan. I mean, simulation is near and dear to my heart as well. Actually, before I joined Foxglove, I was leading simulation for the product end of simulation for an autonomous last mile delivery project at Amazon. And, we had a 60-person engineering team building simulation from the ground up. And we never got to the point even where the Omniverse is and Isaac Sim is. And it really, I think, to me, makes me really excited to see that there are these open source and open free to use tools for simulation, because it's really accelerating the path to autonomy and production for robotics. And in that same vein, that is kind of what we're trying to accomplish here at Foxglove. So, we had a 60-person team that I was a part of doing simulation for robotics. We also had another massive team that was building kind of infrastructure and visualization, logging for and visualization of multimodal data for robotics. And that's what we're doing here at Foxglove. So what we do is, we are trying to basically build the tools you need to understand your robotics, your data logging, your visualization, and be able to introspect your robot and get to production more quickly. So the reason we're doing this is, just like simulation, we view this set of tooling as kind of necessary conditions to building a robotic stack and moving quickly and building it, but they're not actually part of your core autonomy or robotics product that you're trying to build. So everyone ends up building these things in silos over and over. Most of the Foxglove team is, X from, whether it's Cruise or Amazon Robotics or any number of startups that folks have been at. And we've all built these things so many times, we got a little bit tired of it. And we figured, let's go build this once, kind of like Isaac Sim, and give a best-in-class tool that everyone can use, and actually then go focus on what is the core robotics embodied AI problem that I am trying to solve and that I'm actually focused on. So what we have at Foxglove is a kind of set of tools that we offer, and it's actually free to use. And we have quite a few components of it, from our SDKs to MCAP, that are open source as well, that basically enable you to log your data, store it, stream it, and introspect it, so you can figure out what your robot is doing and what's going on with it. So we have a cloud service that you can upload your data to, and it indexes it and allows you to basically stream that data to any of your team members. So the reason this is valuable is, often we see that robotics data can produce something, depending on what you're doing, it can produce on the order of gigabytes per second. If not, you'll probably still end up with many gigs, terabytes, eventually petabytes of data as you work your way towards production. And moving that around and organizing it and letting an engineer have access to that is very painful. So our cloud service allows you to upload that data, index it, and then stream it, basically like YouTube for robot data. But we also work with live data, so you can connect over a WebSocket connection and connect to your robot that is live, or you can replay data and, pause, rewind, and introspect what's going on with your robot logs. So the main thing that we're known for is the visualization of that multimodal data. So Robin is going to demonstrate this in a second here with an integration that we've built with Isaac Sim. And really what Foxglove allows you to do there is, in a drag and drop sort of manner, allows you to explore your robotics data. So let's say you have your robot that is, driving down the street or in a warehouse, and it fails to avoid an obstacle. Well, it could have failed to avoid that obstacle for any number of reasons, right? You could have an issue with your control system, with a particular sensor and just the embedded software on it. Your perception stack could have failed, or maybe your path planning didn't route around it. It's hard to know, but with Foxglove, you can actually pull up several panels and you can see what the different layers of your robot stack are doing and understand what's going on, and make it much easier to really move quickly and accelerate your development. And then, because robotics is such a rapidly developing field, and there are so many different types of robots and so many different types of data that are being logged, we also give APIs and extension points to make it easy to customize Foxglove for your workflows. So all the visualizations that you see in Foxglove are built on something we call our extension API. So we make it easy to basically create visualizations. So if you come up with some novel sensor type that no one's ever seen, or you have some interesting way of storing your data that is completely proprietary to you, you can tell Foxglove via those APIs and our SDKs how to interpret that data and still be able to introspect that information. So the overall workflow, you log data on your robot to MCAP. MCAP is kind of a generic append-only, highly write performant data container for multimodal time series data. It's an open source standard that we maintain, and Kalyan was mentioning is actually now the standard for Isaac ROS. It's also the standard for ROS 2. And part of the reason is because it's very flexible. So you can put JSON data, protobuf, flat buffer, whatever you want into it. You can put different types of message schemas, and it allows it to be a nice standard for actually transporting and logging your robot data. Once you've logged it, you can upload it to our data management via APIs that we have, or via the Foxglove agent that can run on your robot and manage the data on it and make it easy to upload, or a number of other tools that we provide. Or you can just leave the data on a local disk and view it. But from there, you open the data, whether you're streaming it from our cloud, connecting to a live connection, or looking at it locally. You visualize your data, and then you can actually understand what is going on with your robot. And as we've learned, one of the core use cases for all of this is doing this with simulation. So we work with physical robots, but we also allow you to connect to both a live simulation that's running or data recorded from simulations. So with that, I want to hand it over to Robin, who's going to show an example we put together for actually connecting to Isaac Sim.
That's awesome. Very cool. And Robin, which one did you want to share?
The video first, please.
Okay, here we go. Let me see.
Perfect. So before actually explaining how the extension works, I thought it would be best to simply show how it works in action within Isaac Sim. So in this demo video, I'm using one of the Isaac examples, the humanoid one, which come pre-installed with this version of Isaac Sim. So first, let's enable the extension by going to your extension explorer. And under third party, if you search for Foxglove, or just Fox in that case, it'll show up. The first time you do this, you will have to install it. But once this is done, you can simply enable it by toggling it on like so. And if it turns green, it means that it was launched properly. So here you can see a new item in the toolbar, which allows you to open this tab, which is the extension tab. And as you can see, the extension has already detected the different sensors present in the current simulation project. So in our case, we have the 4 standard cameras. We have no IMUs, but we do have an articulation, which is basically the skeleton of your robot, which will allow us to publish the different joint states and transformation trees as well. We do have a settings tab at the bottom here. And what it allows you to do is, first, you can choose a port for your server, for the Foxglove server. So that allows you to maybe have several instances if you need to, or just to select a specific port. You can also set a specific camera resolution to whatever you want, but just keep in mind that the higher the resolution, the slower the simulation will be. And lastly, you can also choose a route for the transform tree. This doesn't change much. It's just for aesthetic purposes if you want to truncate the transform tree and not publish everything. But in our case, we're just going to leave it to the default where it publishes everything. So at the top here, you notice a View in Foxglove button. So this button, if you click on it, will open a Foxglove connection directly in your browser. You will just have to log in. And if you don't have an account, you can create one for free. But in my case, I'm just going to use the desktop app, which I had already running in the background. So if we do go into the desktop application, to open the connection, we simply click on Open Connection, and then we enter the address of our server. So in my case, it's going to be localhost since it's running on my machine. But if you were running it, say, on a different computer, you would have to put the IP of that computer, the one that's running Isaac Sim with the extension. And the port here is the default one, but if you changed it to a different one in the settings tab that I showed earlier, that's where you would change it as well. So once this is done, simply click Open, and as you can see, it gets connected as the timeline starts moving. And then once we launch when we start the simulation, you can see your data being published here live and visualized. But to make it more visually compelling, let's add a URDF. So you can go under custom layers and add a URDF. And since I'm on the desktop app, I'm able to load a file, which I have on my local computer. If you're on your browser, you will have to do with a URL, but it also works the same. And now we have our URDF. And just to show you that everything is visualizing in real time, we can play around with the arrow keys in the simulation to move the robot around. As you can see, there's little to no delay in that case. Everything gets published. You get access to the joint states, to the different cameras that you can choose from, and of course, the transform tree with your robot moving around. But the neat thing is that this reacts to anything you do in the simulation. So say you want to add a new sensor. So let's, for example, let's add a new camera, which will be acting as a point of view camera for the robot. So let's go back in Isaac Sim and then link it to one of the frames linked to the robot's body. So for example, the pelvis here. Adding a camera, let's just rotate it so it's facing the right way and move it around so it doesn't actually collide with the robot. There we go. And once this is done, as you can see on the left side, the extension has detected the new camera automatically and started publishing it, created a new channel for the server and started publishing it. So if we add a new panel in our Foxglove instance and change the source so we get access to the new image that we created, we get a point of view camera, but keep in mind that it only publishes when the simulation is actually running. So for this, let's just start playing it. And we have this newly added sensor that's acting as a POV camera. Again, we can play around with the arrow keys to make sure everything is real time and updates correctly. And that's about the gist of the extension and how it works. As you can see, it runs pretty smoothly. Everything is detected automatically, so you don't have to take care yourself of actually linking every sensor. Currently, it supports cameras, IMUs, articulation, and transform trees, but in the future, we could easily add more support, but this is the first version of the app.
That's amazing.
If
Very
we
cool.
could now switch to my screen sharing in VS Code to actually dive a bit more into how the extension works.
Okay, we'll do that in just 1 second. I just want to mention just a quick note that the video, even though in the tech rehearsal looked great, it's coming out grainy now. So it could be a temporary hiccup with some of the internet. So I think people got the gist of what you were showing, but maybe what I'll have you do is close out the screen, and then maybe we'll try to share it again towards the end of live streams. People can watch it really quick again, and that might help.
Okay.
So anyway, apologize to the viewers on that, but we will we'll try to play it again in better clarity in a minute. All right, so we have this other presentation, I believe. Let me see. This is here we go.
Okay. So before actually showing how the code works, I just wanted to give a brief overview of the general structure. So on the left, you can see the code architecture. By the way, all that code is available in the extension GitHub, which you can find at github.com/foxglove/foxglove-isaac-sim. And the structure here follows the general code template generated by Isaac Sim. But here we really have 4 files of interest. The first one is extension.py, which is essentially the conductor of the extension, as it's the file responsible for triggering the different callback functions that were implemented in the second file, UI-builder.py. As you could expect, this file builds the UI, but it also manages the data collection, since it's where the buttons or the callback functions for the different buttons are called, etc. I actually won't be diving too much into these 2 files because they were mostly generated by the template, even though they were obviously adapted for this extension. But the gist of the code is in the other 2 files, so data collection and Foxglove wrapper. So the data collection keeps track of the different sensors present. It's also the file that queries them. And it also interfaces with the Foxglove wrapper, which runs the Foxglove server, meaning it manages the different channels for each of your messages and sensor types, etc. Before diving in the code, I just wanted, again, to give you a better understanding of what we call sensors here. So each sensor is defined by two things. One, its type, and two, its path, which is the identifier used inside Isaac Sim. So every object that you create inside Isaac Sim has a unique path, which is used to as an ID for all of them. So once you have a sensor, you will have a dedicated channel on the server that will be created. And each channel has a specific topic name, an encoding type, and a schema, which defines the kind of data and how it's encoded. For the schemas, we use JSON or protobuf, mostly depending on the size of the message. And so once you have these dedicated channel, you have to make sure that the sensor data that you collect actually fits into the specific schema. So let's first go into Foxglove wrapper.py. And by the way, this is mostly based on some example files that you can find at this link right here, which is inside the file of the GitHub if you ever explore it there. But essentially, it creates an instance of a Foxglove server asynchronously, which is really important because you want it to run in parallel with the simulation and not being a stopping call. And so every time a sensor is detected, we are going to add a specific channel for that server. And here you find what I was describing earlier. So the topic name, the different encoding encoding formats, and the different schemas. So to be more precise on how this is found, let's go into schemas.py, where here you can see that every sensor type is mapped to a specific schema. So the file is the actual content of the file. The name is what allows Foxglove to detect the format and put it in the right visualization panel. And then just the encoding, as I mentioned earlier, JSON or protobuf. So then it's just a matter here of loading the correct files depending on the type, and then input this back into the channel creation. Removing a channel is pretty straightforward. You just need the channel ID, which is why earlier you may have noticed that we have a mapping and an inverse map from the path to the channel IDs. And then you can simply remove channels like that when you remove a sensor in Isaac Sim. And sending the message here, again, it's pretty standard formatting. All you have to do is make sure that your payload here is properly formatted according to the schemas that you had previously defined. Speaking of sensors, we have in data collection.py a sensor class, which, as I mentioned, every sensor has a type and a path. And depending on the type, we will initialize it in different ways. The way you initialize sensors depends on the kind of sensor you have. I invite you guys to go see the Isaac Sim documentation for more details, and if you want to implement your own. These are just examples of the ones that are supported right now. And then when we want to actually collect the data, it will call the correct specific data collection function based on the type. And just to give you an example with the camera, you can get the RGB frame from the image, and then all the rest is just here to convert it to the proper format so it fits into the schemas that we defined for the camera channel. And then here's just more examples of how you could collect it and format it accordingly so it fits into the protobuf or JSON object. The last class I wanted to talk about is the data collector, which is sort of a wrapper class for the other sensors, as it keeps track of all the sensors in your simulation and as well sorts them just to make some other stuff easier. Obviously, it needs to instantiate a Foxglove wrapper, which we just described. And every time a new sensor is detected, this is where its type is assigned. So again, it depends from sensor to sensor. You can go see the documentation for more information on this. But for instance, if we know that the prim or the object is an instance of camera, then we can easily deduce that it's a camera. But for other types, it's a bit more tricky for articulations. You have to check if a certain schema is applied to the prim. So again, it depends from sensor to sensor, but you can go check the documentation for more information on this. And then at every simulation step, we will collect data, which means that every sensor in our database will be queried and will be stored in a map where we use the sensor path as a key. And this data will be sent then to the Foxglove wrapper, which will publish the individual messages to the correct to the correct topics. And that's about it for how the extension works. I hope this was clear. If you have any questions, I guess either put it in the chat, or you can also go to Foxglove Discord, community Discord, where you can ask all your questions and we'll be happy to answer them. I think we'll put a link to this either already in the chat or later on in the presentation.
Wow, very thorough, pretty awesome. And yeah, we've been posting the links throughout. And I think your colleague Sunny has been hot in the live chat, responding to people really quickly. So thanks for that help, Sunny. And first of all, this is amazing information. So thank you for sharing all this with the community and for sharing the GitHub and going over everything so nicely. And it's really fantastic too that you have such a engagement with the community of users. And I think you guys told me the other day you have a pretty lively Discord server, right? It's pretty big. Like
yes, that's correct.
In the thousands, I think I heard.
Well, we had thousands on our Slack server. We recently moved over to Discord, so trying to remind everyone to move over to our Discord server now.
All right, so I'm sure that's going to be a great resource for people to continue the conversation. We did have a bunch of questions. I know that time just has flown by, but if you all have a few more minutes, maybe we can hit some of these questions, even though we're heading a little bit over time. But this was jam-packed with great information. All right, let's see. Thank you to our amazing producer, Amelia, who has been also helping in the chat a lot, and she asterisked some questions. Let's see if we can do a lightning round on some of these. So let's see, whoever knows the answer first, feel free to just nod or raise your hand or just, throw something at the screen or something. All right, let me see. So here's a first one that came earlier on the stream when Akil was kind of going over the overview of Isaac Sim. Resource for starter project to the platform for simple robot training and testing. Now, Akil, I did post that tutorial that I shared a minute ago. That probably covers this a little bit, right?
Yeah, so that link will give you all about how to get started with Isaac Sim. It's like your hello world. And then there's a sequence of tutorials that lets you sort of build on what you learn. If you want to learn more about robot learning, then check out Isaac Lab, which is also available separately. So they kind of, one is built, Isaac Lab is built on Isaac Sim, so it uses all the components, but if you just want to jump into robot learning, then Isaac Lab is it. But I would highly recommend, if you're new to robot simulation, get going with the Hello World. That's in the documentation. So there's a sequence of tutorials you can work through.
Fantastic. Okay, so we put that in the chat. We'll also update the description after this after the stream ends with some of these links so you don't miss them. If you do miss something or can't find something, don't hesitate to reach out on Discord. You can message me directly, Edmendi, EDMENDI, or you can also just post in the Isaac Sim Discord channel where we have a community of users that are very actively engaged in helping each other. In addition to the official support forum, which exists on the NVIDIA website, which we'll post a link for that as well. Okay, so let me see. This one I think we covered already. Here's a good one, I guess. From Sahin Khan. Do I need to design the robot in URDF or CAD program important to Isaac Sim, or should I design it from cubes and meshes and FBX file? What is the right approach?
URDF or CAD, most CAD programs that I know do support URDF export, like SolidWorks. And URDF is a lot more comprehensive in the sense that it actually does not only have the 3D format, but also the information on the joints, which then can come in directly into your simulation. So it's a much more cleaner way. Kalyan, you're nodding your head, so you work a lot with URDF, so maybe you can shed some light on this one.
Yeah, I think URDF is the preferred one. Like you said, it goes into quite more detail of the joints and stuff. So yeah, absolutely.
Great, thank you both. We have a general question on OpenUSD here. Obviously, we touched on OpenUSD throughout. Will OpenUSD be useful for support people in non-tech background who are interested in Korean robotics? I would say yes. Obviously, OpenUSD is a fundamental way of sharing information between applications and workflows. And Omniverse is the development platform for OpenUSD. On the learning path that we posted earlier with these free courses or modules, it goes over kind of the fundamentals, and you could dive deeper in some of those modules, but you don't have to do all of them. And I think even non-developers will be able to benefit. We also have another overview of OpenUSD available for non-devs on our YouTube channel. I think Aaron had did the superpowers of OpenUSD, which I think are very helpful for everybody. But those links have been kind of shared in the chat, so hopefully you've got a good handle on that. I think it was a great question, so thank you for asking that. Okay, here we go. Is there a thermal camera for Isaac Sim?
Not that I know of, but I can double check. We can ask the experts internally. Off the top of my head, I don't know the answer.
Okay, so we'll check on that, and feel free to post this question also in the Isaac Sim Discord server, and we'll see it there as well. Okay, let me see. Here we go on Isaac Lab. Would you please shed some light on learning Isaac Lab, with Isaac Sim simulation? Kind of touched on this earlier, but you want to just do a little recap?
Yeah, so Isaac Lab is a lightweight robot learning simulator. So it takes all the core components like rendering from Isaac Sim, and it's purpose-built for robot learning. Go head over to the Isaac Lab page. You can go through it from the Isaac Sim page that I showed before, and you'll have all the necessary documentation to get going in Isaac Lab. So think of Isaac Lab as sort of like collection of many, many different things. Isaac Lab is sort of purpose-built for robot learning in simulation. So there's policy-based training, either manager or direct. There's pre-trained policies that you can use. So there's a whole host of intro tutorials as well for Isaac Lab.
Fantastic, thank you. And Barham, I'm very sorry that whenever I put the question on the screen, your face disappears. But it's only temporary. There you are. You're back now. So apologies for that. Okay, we got a good question here too. Let me see. Can we use Osmo for on-premises or home cluster setup?
For on-premise, definitely a home cluster. I don't know what the setup is, but it's meant for if you have a large on-prem setup with multiple various or heterogeneous types of GPUs that can do, simulation or rendering, GPUs that can do training, and then obviously you have your edge-based devices. So it really lends itself in that setup sort of environment. Then also, if you have a on-prem and cloud setup, it can move those workloads in and out. So yeah, it lends itself nicely for on-premise if you have a large setup there. But if you just have one GPU or two GPUs, it's not something that would work for you.
Okay, great. Okay, let me see. Here's another one. What about actuator training? Can you give pipeline for training an actuator that can be 6D manipulator, take simulation data, what type of data, and feed to a real robot?
I think I can take that. So I briefly touched upon it. So we have a model called Foundation Pose, which is part of the Isaac manipulator workflow. So it has already been trained on large scale synthetic data. So it achieves a lot of strong generalization. So it can really see a novel object and be able to detect it. So I would recommend Sanket, please check out Isaac manipulator, and within that the module or the model is called Foundation Pose. And Isaac manipulator itself has a reference workflow that goes through all of these steps. Yeah, I think that may be a good starting point.
Fantastic, very cool. Here's one. Can we use Isaac Sim with a large 3D environment? I guess it just depends on your hardware, right?
Mm-hmm. I think scene generation is definitely doable. I'm trying to think. That's a pretty big space. Before I overspeak, let's figure it out internally. Maybe let's ask our experts. But we do know of customers who are using for large agricultural use cases. So my answer would lean towards soft yes. But maybe Mohammed, you could expand on your question on the forum or something like that, and we can try to get one of our experts to answer that. That'd be helpful.
That'd be great. Thank you for that question. Okay, here's one coming from LinkedIn. I'd like to know if it's possible to use the triggers and callback functions in UI library Pi from the Foxglove Isaac Sim extension on my AWS cloud devices.
Yes, I suppose it depends specifically on what you're trying to do. So the extension is an example. I think we linked in the comments to the GitHub repo there. So you'd have to build it up a little bit, but the Foxglove WebSocket protocol has the ability to communicate both ways. And Foxglove has a publish panel as well that lets you publish out. So some of the implementation details will depend on your robot stack and some of the details there. But in principle, yes, it's possible.
Very cool. Thank you for taking that one. And do you control the robot via Foxglove or Isaac Sim? I guess also for Foxglove team.
Yeah. So for that,
go ahead. Sorry.
Yeah. Sorry. I'll take it. In this case, the robot is controlled by Isaac Sim. Foxglove is mostly for visualization purposes. Basically, it takes the data, the relevant data from Isaac Sim, and displays it for you on the side. And especially, I don't know if you're asking specifically about the demo that I was showing earlier, but the robot was controlled from Isaac Sim.
So important to note, similar to the last question, if you are interested in publishing data to the robot from Foxglove, you can do that either via the built-in publish panel, services panel, or if you're building a custom stack that is not on ROS, you can also create a custom panel in there that communicates over the WebSocket protocol. So you can publish out, but we were not doing that in our example.
Okay, great. Thank you. And let me see. Let's start questions we have here. And you have to reach out to sensor companies and encourage them to add their sensors to the ecosystem. That's a yes.
That's a yes. That's a resounding yes. So we definitely want to add more libraries. There's a certain process to sort of understand how their sensor design works with simulation. So yeah, we have our teams actively engaged with different types of sensor companies. Camera, LiDAR, radar, you name it. And really, our goal is to give you a whole host of library items. And over time, we can sort of build to that. So short answer is yes.
Okay, that's fantastic. Lots of great comments here. I just put one on the screen there, but there are many thanking everybody for the great information here. We've gone over, but it's such great information. Really chuffle. If anyone joined late in the game, don't worry. This live stream is rewatchable at your convenience. You can pause it. And actually, let me ask you, Robin, if you wouldn't mind, try to remove your video from sharing right now, and then why don't you try to share it one more time? And maybe
is it still green? Because I did remove it and
oh, you did? You put it back? Okay, let me see if this works. Let me see if this looks clear. Yeah, it looks pretty sharp. You want to just go through it, kind of like maybe some key moments here?
Go directly to the demo.
Here you go.
After URDF is loaded.
There you go. It looks very sharp. So there you go in its full glory. And again, if you missed anything or want to dive deeper into the great work that Foxglove is doing, their website is the best place to start. Additionally, their Discord server is a fantastic resource. I want to thank both of you very much for coming on the live stream today. Thank you, Sunny, for helping out in the background with the great questions. Kali and Akil, amazing job as always. Really fantastic. I'm so excited about these next live streams we're doing on robotics. As I mentioned earlier in the live stream, it's really one of the most engaged topics that we see on the forums and on the Discord server. So many people, so many companies just diving in and leveraging. So really great timely information provided by both of you and from the Foxglove team as well. With that, I will wish everybody a great rest of the day, and we'll see you next time. Until then, definitely feel free to join us on the Discord server, the Omniverse Discord server, which is discord.gg/NVIDIA Omniverse. And feel free to shoot me an email if you need any information, edmar@nvidia.com. And actually, for anyone who might be in a startup, I think I have a quick Inception video, a minute and a half, that gives a nice overview of what Inception is. And I think since Foxglove is here, maybe this is very timely to play it now. So we'll say our goodbyes right after this video finishes playing.
NVIDIA Inception is partnering with thousands of the world's most innovative companies, startups at the forefront of AI, data science, gaming, and other breakthrough industries. NVIDIA Inception is the free program that empowers startups through every stage of their life cycle. Learn how you can fast-track your path to success with these program benefits. Accelerate your growth with credits for technical training, online forums, and expert guidance. Jumpstart your development in the cloud, on-prem, and at the edge with over 150 NVIDIA SDKs, pre-trained models, cloud credits, and preferred hardware pricing. Explore funding opportunities and introductions through the NVIDIA Inception VC Alliance, a community of investors excited to connect with you. Strengthen your startup's visibility through exclusive events, speaking opportunities, and promotional support.
NVIDIA seems to be one of the few, if only, companies building a robust startup program.
No matter what your size or funding stage, NVIDIA Inception can accelerate your growth. Join our global community of innovators today to see what's possible.
I always get so excited watching that video. Okay, well, thank you everybody for joining us today out there in the audience. Thanks for the amazing comments and questions we saw throughout the chat today. We'll see you next time. As I said, we're going to be doing more robotics live streams over the next coming weeks. I think we're planning a nice community spotlight for October 23rd. So if you have a great project leveraging NVIDIA technology and robotics, we would love to talk to you, maybe show it off in a live stream, maybe talk about it in a blog, or absolutely feel free to share it with the world on the Discord server and the Share Your Project channel. Thank you everyone for joining us. It's been fantastic, hour and a half now, an hour and 15 minutes. So it's been fantastic. So thank you all. Any last kind of comments before we go that maybe we forgot? Looks good. I think we covered it. We covered everything. I think this is actually, we should put this out on DLI. I think this is a great webinar also. So thank you everybody. And the Foxglove team, best of luck with next steps. I'm really excited as your company and community grows. So congratulations to being part of Inception.
Thanks so much.
Thanks everyone. Thanks everyone. Bye now.
Bye.